presentation in a series on geometry. Geometry is a widely known subject, and so it behooves me to state a little bit more about what I am doing. What am I doing with geometry? My premise in science is to study heaven. This is one of two courses, obviously, where the other one would be Earth. Earth and heaven are obviously related. They are given two different names for a specific reason. We dwell on earth and will never get to heaven. Now that raises a question in our minds as rational men. So the subject of my lecture, and continuing until the solstice, will be, what is our position in the universe? It begins, obviously, on Earth. But that leaves open a very wide field, which is basically everything over our heads. This would be traditionally the study of astronomy. That is the correct word, and that is the way I use the word. The study of heaven. Heaven has a history which perhaps is objectionable from one side of any person. I myself am involved in this dichotomy where we are talking about heaven as if it were something separate from the earth. Physics teaches us otherwise. And so the course of science brings into communion, into correlation, our position on earth with our position in heaven. And that raises a question which has a structured approach for an answer. And that science is called geometry. In the study of astronomy, the subject of trigonometry comes up. This would be the use of our linear system, basically our system of vision, where we produce from our visual perceptual space an onboard system with which we were born. Very important point we'll come back to. We see linearly. We have two eyes in the front of our head which are able to produce a parallax, two straight lines converging on a point. From that we can get a midpoint between our eyes. That's putting it perhaps dramatically, but that is the essence of geometry, is trigonometry. The word trigonometry comes from a word from Greek, which means three. Three lines making a triangle. From this, we have derived all of science, and there is no aspect of science that is not touched by geometry. And so one might ask the question, perhaps at junior high school age, perhaps before that, but definitely by high school, every single man, women are always included when I say man, every single man faces geometry. It is the highest calling in mathematics, and mathematics is a tool of geometry, and mathematics is a slave. Mathematics has achieved the position of godhood because of technology. That is an extraordinarily imbalanced situation, which has caused repercussions all the way to astrophysics and to subatomic physics to the quantum level. Nobody today practices geometry. I urge you and dare you to look. Of course, it's inescapable. And even today, at the highest levels of astrophysics, talking about Einstein's spacetime, which now is the dominant geometry, it has been so shot full of holes from every direction that no matter what your religious outlook is on spacetime, that you just love it. I certainly do, and so I'm intimately involved in this controversy, this incredible problem, this superb paradox of what is the geometry of the universe. And I am now going to be addressing a high school audience and nobody beyond. If you're a PhD or a Nobel laureate or you have some other accreditation, you are fully entitled to sit in on this lecture. But I am not talking to you. I'm talking to young men, always including women. And believe me, there are some dynamite women mathematicians, astrophysicists, and I haven't heard of any quantum mechanists who are women, but I'll bet there are. This is for high school age. Now, my subject is geometry and the universe. And the way we're going to begin is with this man, 2 hours left. And his name is Roger Josip Boscovich. This man you will look at, he lived, basically you can think of as in 1800. He was a contemporary of Leibniz, who was a contemporary of Newton, all three of whom lived before James Clerk Maxwell, Max Planck, Albert Einstein, and Paul Dirac. These are the 7 men I am going to be talking about. I believe I left out Newton. He's the 7th. But this is one of the 3 earliest of the men in history in this list of 7. Roger Josip Boscovich is coming back into the front line of science today. He achieved an expertise in geometry which has not been surpassed by the astrophysicists or by the quantum mechanists. And that's why his name is starting to come back up. I'm currently reading his book, and from now until the solstice, I will be involving you as well as myself in the amazing production of Boscovich's curve. This is a curve. This is your first lesson in geometry. All of you high school students of the future who will be listening to this lecture, this is about curvature. And your first lesson in geometry is that a curve is not, let me emphasize that, a curve is not straight. I hope you can grasp that. But that is the problem. So, you will notice from this painting, and it is an oil painting with a very bad granularity on this screen. I'm not sure if this painting can be observed in any museum, but this is a rare photograph. I'm sorry I keep saying that. The reason I keep saying photograph is, doesn't it look like it's kind of a fuzzed out photograph? Well, those artists back then could do a magnificent job, and they certainly had to, because there was no photography. But he lived around the last half of the 1700s. That's going back. Let's see, if that were 1775, and this is 2025, just rounding it off, that's 2.5 centuries, am I right? 20, 19, 18, yeah, 2.5 centuries ago. I want you to notice that he is sanpaku. This is a Japanese term for when your eyes are, let's see if I can do this. I don't have it. I'm the opposite. If your eyes are always pointing up, this photograph, oh God, I said it again. This oil painting shows his eyes in a fairly standard position. Your eyeballs should be about centered. According to the Japanese theory, they should be about centered between your eyelids. If they're, I can't actually do it. Oh, there. No, that's the opposite. There. If my eyes were just rolled down, there, I'll do it. If they're always. No. Wait. If they're always like this, I can't see myself, so I hope that looks right. When the whites of your eyes show underneath your iris, that means you're san paku. We're not really interested in that, are we? But it gives you because I want to say something about him. He was an extraordinary man, and he has been called by people smarter than me. That is, well, they might be smarter than me as well, but people more informed about Josip. That is, his name is spelled in Croatian and in Italian and in French, and then now we have it in English, and we're not sure what to say, but his first name is Roger. So I believe that's pretty cool. In whatever language his first name shines through as Roger, it's Ruger. And I'm sure I'm mispronouncing it because I'm not Croatian. He is. And he spoke Croatian and several other languages, including Latin. I'm reading his book in Latin. No, it is in Latin. It's on every other page. And I'll give links for where this book may be acquired. Boscovich is now rising back up into the limelight right along with Dirac, Einstein, and everybody else, even though he lived so long ago, is because he discovered a geometric relationship between particles which defines the electron orbital shell system and pretty much everything else in forces. And so his theory, when you sum up, he would say this too, he would agree with me, this is his theory. It's a theory of forces. And that is not how anybody looks at the universe today. And so I'm going to be covering very quickly this evening a brief recount of how we got to the situation we're in science at the two cutting edges, going out and going in. We're trying to find the building blocks inside the atom, whatever we can find in there. That's quantum mechanics, by the way. And going out the edge of the universe, the galaxies, the superclusters, the black holes, everything else. Pulsars, well, those are stars. Quasars, which are not stars, they're incipient galaxies. Gamma ray bursts at the very edge of the visible universe. There are things that have not been discovered yet, but we've already identified the cosmic microwave background radiation, which, for your information, and you can take it from me because I've been studying this for 15 years, the cosmic background radiation is predicted by any theory. And so it's no proof of the Big Bang at all. Now, the Big Bang people would argue that they would have me for lunch. Not anymore, they won't. But the cosmic microwave background radiation is about, I believe it's a 27 degree Kelvin. It's called microwave because there's several ways that you can state what you're seeing, which is a fuzzy light at the edge of the universe, which is, oh crap, are we excited about that? I am. And it should be explained. Nobody's explained it yet, but everyone's trying. And so we do have a current cosmology. Disregard it. What you need to do is discover the cosmology that will fit your mind. And if you have to shoehorn it into your mind, as these present-day cosmologists are definitely doing, just shoehorning what they know has to be true because the mathematics tells them, what are they missing? I will be showing you that. It's called geometry. Now, so you know where I fit into this as I give you this brief lecture, and we're only at 15 minutes, so I'm doing well. We're going to show you some other photographs. It's not just Boscovich. And so let me switch over here. And the way I fit into this, I'll be able to show you in a moment as soon as I get you the next photograph. There he is. Sir Isaac Newton. Isaac Newton of England. Rather famous. I don't really need to fill you in on anything about him, but I chose this particular portrait of Newton because it shows him as being somewhat human. It's pretty obvious that he has no chin, a very long nose, kind of bulbous eyes. He's a normal looking man. There's nothing wrong with him, but I think you've seen other portraits which were done by professional painters where you could just hear the conversation in the background. Now, Sir Isaac, I'm going to paint you with a really strong chin, a nose that's not quite protuberant, and your eyes, instead of just being like, oysters swimming in a dish of cream, gonna make you with a penetrative look like you're looking into the future with a really strong chin. I probably should have a photograph for that. But there's no denying, I don't care what you think, feel, what I think, feel, or about Sir Isaac Newton, that guy really changed a lot. Why? Hyperbolic geometry for the trajectory of planets on an orbital path, capitalizing on the discoveries of Kepler. Newton systematized it into a hyperbolic geometry of the third order. That is also coming back up for review because Sir Isaac had some presuppositions that Boscovich picked up on, and Sir Isaac was contemporary with Leibniz, and I think they had a kind of a disagreement, which is all entirely due to Newton. And I could just give you a brief blurb. If you're not aware of that controversy, they both invented the calculus. It's obvious that Leibniz got it right. And Newton kind of got it right, but he knew what to do with it. Leibniz didn't really apply it very quickly, but Leibniz's notation is used today. Leibniz got it first. But what happened is that Leibniz visited England. He did. At the time, just at the right time, so that after he went back to the continent and, published his stuff about calculus, Newton had been lagging in publishing his calculus. There was a black plague sweeping through England at the time, so you can forgive anybody for whatever they did, I think. But back on the continent, Leibniz heard word that Newton just freaked out. Freaked out. He was a very irascible, nasty man. I don't really particularly like Newton from what I've heard of him, but I don't care. I don't care if you do Copenhagen snuff and stuff it under your lip like a slob. If Newton were drooling Copenhagen, I would still respect him. I don't care if he hated puppies. Get me? But when it comes to the controversy over the calculus, I want to say two things to help you high school students orient towards calculus. First of all, I will teach you calculus because there's only one right way to learn calculus, and apparently I'm the only person who realizes that. I will teach you calculus. Not in this lecture, but very soon. I have in the past. I have 250 videos, and I'll have links if you want to know the calculus. You need to have the right geometry. Now we're back on topic. Let's go to the next guy. I'll have to switch over here. We've covered two men. Let's get a look at Gottfried. If I can click on it correctly. Did that do it? The hell's wrong with Gottfried here? Hello, Gottfried. Oh, I think I have more than one highlighted. Oops, there he is. That's Gottfried Wilhelm Leibniz. Now, I said it wrong. Leibniz. You may encounter a problem spelling Leibniz's name because the sound at the end is ts. Shouldn't that be two letters? In German, it's just one, a Z. but in English you will see it spelled Leibniz with a TZ at the end. I'm just saying that. Now, doesn't he look like Bach? Johann Sebastian Bach? He kind of does. He looks even-keeled, doesn't he? He doesn't look intense like Newton always did or tried to. He doesn't look dreamy-eyed like Boscovich. Boscovich, by the way, I meant to mention this, he was a priest, and a very good one. Boscovich was a member of the Jesuit Order of the Roman Catholics, as was fairly common in Europe at the time. And he was a goddamn priest. I mean, I respect Boscovich enormously, and my opinion of the Catholics has been going up and up and up since I was brainwashed by some Protestant organization I won't name, the goddamn Seventh-day Adventists, who fucking hate the Catholics. Well, take a look at their record. They don't even have the Sabbath right. Ha ha! And their whole name and identity is based on getting the Sabbath right. Just a little background on how I get so emotionally involved with that. I was a Seventh-day Adventist for 15 years, and I tried to point out that there are 7 Sabbaths, and no. And that was bad enough. They kind of shunned me after that. But I kept going, and I became a missionary for the Seventh-day Adventist Church to Ukraine. So I went there and lived there, and then things happened. The CIA got involved, I think. And the school closed down, so I lived there illegally because I was in love with the princess of Ukraine, who was 19 years old. And I ended up marrying her. But that's a little history of my involvement with Ukraine. So now our next guy that we want to visit. I haven't said anything about Leibniz. He had not really a very good geometry, but what he did have was a very good calculus. Also, he had a theory called continuity, and every single one of these men has some aspect, some part of their theory has to do with continuity, which we'll be talking about. It's a geometrical concept, and Boscovich picked up on it. And that's all we'll say there. The next guy we've done, here he is, James Clerk Maxwell. Now I say Clerk because that is a Clerk, and some men's names you just always give his middle name. And everyone always gives James, Jimmy's. He was a Scotsman. I love this portrait of him because it doesn't look anything like any of his other portraits, because he grew this gigantic, fucked up beard that made him look hideous. And then he died of stomach cancer at a very young age. So that's James Clerk Maxwell. What is the significance of his role in what I'm trying to present to you about the universe and about geometry? He came up with some equations for light. And this was, it's very well known now. It's called electrodynamics. One of the most, and I warn you away from that. Do not try to study electrodynamics if you want to have a normal life. Because if you start to study electrodynamics, first of all, your chances of getting through the course at the graduate level are about 40%. And if you do make it, you'll probably be a millionaire. So there is a great incentive for learning electrodynamics. But of the 60% who drop out, there's a certain fringe group that they lose their minds because they know they have to get through this or they'll die, and then they realize they can't. And that can happen very easily. That also can happen at several levels. I'm going to protect you from that. You do want to study these things, but what you don't want to do is get into the mathematics too deeply. Because if you do, you'll be lost to the way of heaven. And that is what I talk about. I am a priest. I'm more of a priest, or at least as much of a priest, as Roger Boscovich, or anyone in the Catholic Church, or anyone in any church. I'm a scientist. I'm supposed to be a priest. Supposed to be. What does that mean? Is to guide men to heaven. Isn't that a good definition of a priest? Guide men to heaven? Well, the only men who have ever guided men to heaven have been astronomers. Okay? That is your first lesson in geometry. You want to know geometry? You better know what it's for. The mathematics is a tool for geometry. All right, I'm mounting my pulpit, so let's not do that. So I'll get back here and we'll go on to our next fellow. We want this guy now, Max Planck, and this has a quotation on it, which I'm pretty sure you can't read, but let's see if we can just do something. Oops, oh dear. I want to be cautious here. I'm not too technically wise yet, although I will be. Did that help? No, because it's not on top. Well, I think you can see the whole quote. Science cannot solve the ultimate mystery of nature, and that is because, in the last analysis, we ourselves are part of nature, and therefore part of the mystery that we are trying to solve. He just contradicted himself. I hope you noticed that. It's actually a circular argument, but I want you to look at his face. Does that guy look like he's been through some shit? If you want... We moderns, myself, I'm a perfect example. This just baffles me every time I read the lives of these guys. You get interested in the scientists themselves. Max Planck's life is just an endless series of tragedies. He just died a very, very unhappy man. And yet he made the greatest breakthrough in the history of geometry. And it was a discovery in mathematics. And he didn't think it was geometry or mathematics. He thought it was physics. But what he discovered, I discovered some things about what Max discovered. And his major discoveries, there are two. One of them is the counting number system for universal mathematics. The counting number system that the universe actually uses. And his second discovery is the equation of light. This goes so far, and he did not believe that he discovered any of what I'm saying. What he thought that he tried to deny that he discovered anything at all. He didn't want to discover it. He discovered the quantum. And what I discovered is what the quantum actually is, geometrically. That is a major discovery, but I'm not here to toot my horn. Let's go on to the next guy. And here he is. That's Paul Dirac. The reason I chose this very unusual and rare photograph of the young Paul Dirac is that it shows him as a normal man. Paul Dirac was considered to be, by those who met him, quite an eccentric sort of a person in a morbid way. He avoided people. He really wasn't very communicative in a certain social sense. He was just a loner. He turned people off. Some people said he must be autistic or he was just a weirdo. Let me tell you something about Paul Dirac. He was none of those things. He was the most cultured, gentle, wonderful man, but he had a calling. He was among four men, 4 or 5 or 6, it's hard to say, it's the beginning of quantum mechanics. He got the correct, or mostly correct formulation of the quantum mechanical waveform under relativistic mathematics. That was quite an accomplishment. And there are several versions of quantum mechanics. The Schrödinger version, the Heisenberg version, there's another one, and there's Paul Dirac's, and that stands alone. and it is definitely incorrect. That has been demonstrated conclusively by a modern astrophysicist. He calls himself a mathematician, Dennis Morris. Shout out to MR. Thank you for your comment. From watching Dennis Morris's expose of the Dirac equation, I came to realize just exactly why Paul Dirac is legendary. And that's the end of our sequence. I don't have a photograph of Albert Einstein because I think you know what he looks like. Probably the most famous man who's ever lived on the face of the earth, with a possible exception of you fill in the blank, because you know the beauty pageant thing. You're never right when you say someone's the best or the greatest or the... Sometimes you're right when you say the first man, but when it comes to quantum mechanics or astrophysics, you're rarely right when you name a man. Everyone stands not on the shoulders, but on the database of what came before. So, we're now at a half an hour, and I would like to switch back now. It's going to take me a moment to do this, but I'll keep talking while I'm doing it. So the subject of this, we're going to cut this off at 40 minutes mercifully so I can edit this somehow. Gravity and light. When you want to study the universe, you want to study mathematics, you want to study geometry, you want to study reality, finally you're going to get down to two things. If you're studying astronomy, you only have two ways of doing it: gravity and light. We will never touch the universe. We're not going to send probes there. We're not going to land there. We're not going to the stars. We're sitting right here on the spherical surface of the Earth looking out through telescopes. But it's pretty obvious that the Earth is controlled by a force called gravity. We've also found out, believe it or not, the sun has gravity, and that's why the planets go around it. We've extended that after Hubble discovered what galaxies actually are a century ago, not long ago. Those have gravity, but that gravity has never been understood. That's a remarkable statement, that galaxies do not obey the law of gravity. And this has caused a you-know-what storm. We'll be covering that because you need to know some things about basic geometry and basic forces. Now, when you're talking about gravity and light, you're talking about force. Light goes out, correct? Light never comes in. We think of it coming into our eyes, but that's because it went out. Where did it come out from? Where does light come from? It comes from electrons. Electrons produce light. That is a simplification because I didn't state it geometrically correctly. But basically, a ballpark statement, if you had to just sum it up, it comes from electrons. And those electrons are in stars, and stars give off light because the electrons release what we call photons. Photons are a highly controversial object. They're accepted by the Standard Model, but I'll tell you why they are accepted as such, although they're not anymore, and cannot be, and never will be again. But for the longest time, photons were a major issue. And they're still called photons, and you can call them photons, but unless you know the geometry of what you're talking about, you will never accurately understand or portray what is a photon, because we know now it's two things, but nobody can distinguish between them, because one of them has to do with geometry, and the other one has to do with geometry. But the problem is they're two different geometries, and mankind has only discovered one geometry. Unless you include me, Scott Allen Miller, whose name will never be attached to this if I get my way, but your name might be attached to it, the second geometry that was discovered in 2022. The geometry of the sphere. And light obeys the geometry of the sphere, spherical geometry. Nobody knows that yet. And that is the problem. And the problem that you're going to face as high school students when you study geometry, as I'm going to command you to do, because it's your only rational choice, is to study geometry. Now, you will have to study everything else as well. I'm talking about focus. I'm talking about orientation. I'm talking about understanding. Do you want to understand the universe? Then you're going to have geometry. Because the only way that the universe can be understood is geometrically. It cannot, and let me repeat this so you hear it very well. The universe, beyond the solar system, okay? Whatever is the starry realm, it's 1 billion times bigger than anything we knew a century ago. All right? So this is very important. That billions of times bigger thing that we call the universe is geometry. It's geometrical, and we need to understand the language of the universe, which is geometry. Is it mathematics? I will prove to you that it is. But is it linear mathematics? I will prove to you that it is. But if that's all you know, you can join the ranks of the current astrophysicists and quantum mechanists who will never understand the universe, ever. Because unless you understand the other geometry, which is not linear, you won't understand the universe. Period. And that's 40 minutes. The lab cat did not pay a visit. I hope you've had a chance to read this, but in the next lecture, I'll be expounding on what's on this page. And that's exactly 40 minutes. This is Anna Galactic, broadcasting to you on Friday, January 27th. With the first, it's lighthearted for now. I haven't borne down yet, but in the upcoming lectures, you're going to be tested to the limits of your ability to understand anything. Because I'm going to force you to see. That is what a priest does. We'll be right back. Stay tuned.